Hello everyone. In this video, I'm going to go over the interaction models. I'm using the Census Population Survey CPS of 2008 dataset. I have already started the do file, which is the start phase of a do file where I'm creating my path and creating the log file to receive all the results, and then I'm calling the dataset. So what we're going to do is we're going to first of all, we're going to start with the main model without any regressions, without any interactions, and then I'm going to talk about interaction. We have many types of interactions, so let's start with interaction between two dummies, and then I'm going to talk about interaction one dummy and one, and so let's start. Let's get the data set and let's create the main model by regressing average hourly earning on two variables, bachelor, female, and let's use robust standard error because I know this model would require a robust standard error. And then let's do the interaction models. Let's start with interaction between two dummies, and remember, whenever I have an interaction between two dummies, I need to think about 4 different questions or 4 different cases. So let's generate an interaction between gender and education, which is equal to female times bachelor, and let's add it to this regression model. Okay, and then let's run everything just to make sure that no typos, no mistakes. Okay, so education adds to the average hourly earning $8.3 per hour. Female decreases average hourly earnings by 3.44 approximately per hour. And the interaction term between female and bachelor even adds to the negative effect of female or negative effect of being a female. So the best thing to do is to extract these coefficients so that we have nice way of displaying results. So we basically need to extract these coefficients by creating a scalar for the intercept and other coefficients in the model. So for the intercept, it's underscore from the matrix beta, and it's underscore again constant. And for the partial slopes, let's say we need to do one for each. So we have slope female equal, again, underscore from the matrix, square bracket. We don't have another underscore for the variables. Like I only have an underscore for the intercept, but the other variables does not have. So this one is going to be female, and you close the bracket, and then scalar slope of bachelor equal and the last one. So for the interaction, female bachelor is equal to the underscore from the matrix B, square bracket, interaction, Okay, and then the nice thing about extracting these coefficients, just making sure that nothing is, you don't have any mistake, nothing is wrong. Okay, and then keep going. So we display the results, display. So suppose I'm asking you to get me the average hourly earning for a female with no college degree. So so you would display the results of the average for a female with no college degree and equal, and then leave a space, and it's going to be something which is dollars per hour, and you close the quotation and make sure you leave space here so that the numbers are not connected to your sentence. And for to get this, we basically need the intercept, we need the slope of female, right? So this one would be intercept plus slope female. And let me bring this. Okay, so the intercept is the coefficient of this regression. I'm asking about a case of a female, so this number is taking, this variable is taking 1 and no bachelor degree, right? So this one is 0, 1, 0. So I'm left with the intercept and the coefficient of the variable female. Suppose you can make so many questions out of this result. Let's say I'm asking you to repeat, but for a male with no college degree. So for a male, this coefficient is taking 0, so I'm left with the intercept. Suppose I'm asking you to do for a female with college degree. Then with college degree, I have this one, I have this one, I actually have everything, right? So I have also the slope of bachelor, and I also have the slope of interaction of female and bachelor. Okay, what if I'm asking you to do the same thing for a male with college degree? Okay, so what's the average hourly earning of a male with college degree? So you will have the intercept and you will have the slope of bachelor. Okay, we can also have a question about the discrimination. So what is the magnitude of discrimination in average hourly earning between male and a female, and let's see, let's make them with college degree. We can also have a discrimination with no college degree, but let's see the question with college degree. Okay, so what's the magnitude of discrimination in average hourly earning between males and females with college degree? So in this case, I'm kind of comparing a male with college degree, which is this number. So let's copy it. And of course, this number is going to be bigger because we expect to have a discrimination. So we expect males to earn higher, subtracted from how much females earn. So let's take this one. Okay, and then just make sure you have the brackets. All right, and this would give you the discrimination, and we expect this number to be smaller than this number, so I start with this one first. Okay, and let's run this and see. So this is we did already up to the scalar. Let's display the results. So displaying the results, read here. So the average hourly earning for a female with no college degree is 13.15, approximately 13.15 dollars per hour. Of course, males make more, so $16.58 per hour, both no college degree. The third case is a female with a college degree. She would earn on average $20.87 per hour. Males would make about $4 more. So males with college degree would earn on average $24.98 per hour. The magnitude of discrimination is this number minus this number, so you would get it right here. Okay, so next, suppose I want to test two coefficients, right? So let's say I'm asking you to test whether female and interaction are statistically significant, right? So let's say you have this regression, and let's read here, and I'm asking you to check whether female and interaction are statistically or jointly statistically significant. So you can do the test PARM of both together, which is the F test. Remember that you can also do test, so both would give you the same answer. So, so you would run this one and you would get, there is a 0 probability that these two are equal to 0. So if you have a question about whether to omit the interaction term from the regression, no, the interaction term makes sense because it is statistically significant with the variable females. We can, again, you can actually do the other one, so we'd give you the same answer. So some students will use test PRM. I'm used to use test PRM, but it's up to you. You can also check the statistical significance of the variable bachelor, right, with interaction. Oh, sorry, my mistake. So you can check these two together, right? And again, there is a 0 probability that they are jointly statistically insignificant, or they are jointly statistically significant. Okay, so you can just write here the coefficient of female and interaction of female bachelor are jointly statistically significant based on the F test under all conventional levels. And the same also goes with the other coefficient, which is bachelor, right? So this would be a question about joint significance. Okay, next let's do the next one, which is interaction between one dummy and one continuous. So I know we have bachelor, which is a dummy. I know we have female, which is a dummy. We have the variable age that we haven't used. So let's create a dummy out of this variable. Of course, I can use female and bachelor to create to have a dummy versus continuous with age, but let's just show you something different. So we can we can create a new variable. We call it dAge, or it's a dummy for age that is equal to age greater or equal to any number. Let's see what's the variables here. What are the variables here? So age goes to 33. Okay, we have 20s, we have 27, 29, 26. So let's make a cutoff. I'm just gonna make anything, okay? So let's make a cutoff of 29. Of course, you can choose any number. I'm just playing with this model. I mean, I didn't like choose 29 based on a specific reason. I'm just choosing a number, and I want to show you how to create a dummy. So we're going to create a dummy that takes 1 if age is equal or greater than 29, and it's going to be equal to 0 otherwise, or otherwise less or strictly less than 29. And we want basically to answer a question: is age above 29 makes a statistical significance difference on average hourly earning versus age below 29. So we generate this dummy. Let's generate an interaction between age and itself as a dummy, which is equal to age times dh. And we're going to add it to the regression. Let's have this regression of average hourly earning of age dh interaction between age dh. Let's have this simple model, okay? And let's run it. So we have generated this variable, we have generated its interaction, and we have regressed. And the variable generated is dh right here. So when you go to the data editor, you would find a variable dh that takes 1 every time the person is above 29, and it takes 0 if the person is below 29. And we're using it in this simple model to see whether having this is equal to 1, which is a person of age 29 or more, would have an effect on this average hourly earning. If it turns out to be insignificant, then basically there is no difference. So let's look here. What we can see here is the dh is statistically insignificant. The interaction is statistically insignificant, right? So what can we say? We basically can say that, just to note the following, so I want you to note the following. dh adds to the intercept of the mean regression. What is the mean regression? Which is the regress AHE age. Okay, so this is the mean regression. If I add dh to it, then it's going to add to the intercept. Okay. The other thing to note is interaction term of age dh adds to the slope of the mean regression, which is regress AHE age. So those are things to understand. So the dh adds to the constant. So the new constant is going to be 5.09 whatever minus this number, and the new slope is going to be this number minus this number. However, we ended up by having insignificant interaction and insignificant dh. So this is basically telling us there is no need to add these two, right? Because the adding dh to the model would not provide me of a statistical significant addition to the intercept, and will also not provide me with any statistical significance addition to the slope. So there is no reason actually to add them. You can also write it as follows. Using 5%, or actually it's at all significance level, using any conventional significance level, age above 29 has the same effect on average hourly earning as age below 29. What else we can say? Can we test whether the two lines are the same? So suppose I'm asking you to test whether the two lines have the same slope. So what are the two lines? Actually, I'm saying line 1 is the mean regression, which is regress average hourly earning and age, and line 2, which is regression 2, you can call it regress AHE, age, DH, interaction, age, DH. So I'm asking you to test whether the two lines have the same slope, and the only addition to the slope is this part. Like, definitely they have the same slope. I mean, this is age and this is age. What is the addition to the slope? I'm basically talking about the part that adds to the partial slope that is continuous, which is the interaction term. So this one is exactly equivalent of check the t-stat of the interaction term, because the interaction term is the only addition to the slope. So when I look here, I only need to check this one, and your conclusion is basically, again, it's under all conventional levels, right? So under or using any conventional significant level, both lines have the same slope. Okay, because actually the addition to the slope is insignificant. Next, how about, so these are, I just prefer to leave spaces so that it's easy to read. Okay, so we have like now these notes. What else? We can test whether the two lines have the same intercept. It's equivalent to checking the t-stat of the dummy, or I would say, which is DH, because DH is the only thing that is going to add to the intercept of this relationship. DH is the only coefficient that can add to the, that we can add to the 5.09 here, which is the intercept. Okay, so you need to check the of the dummy or TH in this example. So to do that, we actually have the dummy is insignificant, okay? And based on that, again, you can actually repeat using any conventional level, both lines have the same intercept. Why? Because the DH is statistically insignificant, okay? One thing to note here is using, so we have, okay, same effect as age below 29, and this is equivalent of check the joint statistical significance of the dummy and interaction. So I just want to add this to here. So when you have this regression, like we have it here, we need to check the test. Okay, let me add it here so that I have all the green comments together. So test PARM of the last two parts. I already can see that they are separately insignificant, so that's why I was able to conclude that they are definitely jointly insignificant. So as you can see, there is a very high probability that these are equal to 0. Okay, so they are statistically jointly insignificant, and that's why when I ask you here to check whether the age up of 29 has the same effect on average hourly earning as age below 29, then you basically check the statistical significance of the two coefficients combined, okay, or f-test, okay. And that's why we were able to tell that they have the same effect, because adding the interaction term does not have any impact, and also adding the dummy of age does not have any impact. Okay, so these are the notes, and I would consider these notes as kind of 3 possible questions. So this is note number 1, by checking 2 things, dummy and interaction, f-test. And then number 2, so in number 2 we are only checking interaction term. In number 3, and that's why we're using a t-statistic, in number 3 we are checking the intercept, or the t-statistic of the intercept. So you would think of number 1 combines 2 and 3 together by using an f-test, and these are the possible different conclusions that we can get. Of course, interaction models can also have, let me just close this one, and I want you to note that we can also have a third type, which is the easiest, which is an interaction between two continuous variables. Unfortunately, I don't have 2 continuous variables in this model. I have only age, right, which is the only continuous variable, but this one is kind of the easiest one. So I might be showing it to you in a different, using a different data set, because this one does not allow me to have an additional continuous variable besides age. But this is just for completeness. Remember that we are basically talking about 3 types. So interaction models are 3 types, okay? We are mainly we basically focus on the 2 dummies case, and the dummy and interaction, and a dummy and a continuous variable case. And this one I'm gonna say to be continued. So I'm going to look for a data set and send a video for the 2 continuous variables. Okay, if you have any question, please let me know in the discussion forum. Thank you.